Here are the video notes for Chapter 15, Section 3, Part 2. So Part 1 really covered kind of Darwin's ideas behind it. Well, what evidence did he kind of use to back up some of his claims? Well, Darwin argued that living things have been evolving on Earth for millions of years. So some of the evidence that can be used for that are found in fossil records, geographic distribution of living species, the homologous structures of living organisms, and similarity in early development, so embryology. So the first part is the fossil records. So fossils are any evidence of past life in rock layers. And they could be the remains of living things, or they could also be fossils that include nests, footprints, scat, feces, that type of thing. Fossils have developed a chronological timescale of evolution of several types of organisms. So basically what has happened is we can look at these fossil records and look at kind of the organism in its current state today and kind of see this progression, this evolution for it. From the fossil records, we're also able to determine several mass extinctions based on the number of fossils deposited at certain times. And remember, we go back to Hutton when he was looking at kind of the rock formation, that type of thing, and looking at the different rock layers and when they were actually formed. So we can kind of get this chronological order of different fossils based on that. And one more kind of link that shows us is the Archaeopteryx. So the Archaeopteryx, we can kind of see here, this is just a pictorial kind of image of what we think it would be based on some of the fossil records that we have. And it's the fossil remains of a transitional, kind of the transition between reptiles and birds, has the characteristics of both classes. So for reptiles, we have the teeth, the claws, the bony tail, and for the birds, they have some hollow bones, feathers, the wishbone. It was discovered in China in 1861. But I'll give you another kind of look here. But what this goes back to is this idea of this fossil record being able to show kind of the progression of a species, showing how they have kind of developed over time. And that's what Darwin kind of used in some of his information as well. Looking at some of those, how things have changed to kind of support his ideas as the natural selection and the evolution of different species. We also have geographic distribution. So remember, Darwin's voyage was really around the world, and he just didn't take specimens from the Galapagos Islands. He was taking specimens kind of from all over and just taking observations from all over. And what he noticed is that there was kind of these similar organisms kind of throughout. Remember, he had kind of said, oh, these certain animals looked maybe different, slightly different, but they had very similar characteristics. So if you actually look on your book on page 383, they look at kind of the beaver, the muskrat, the capybara, and looking at how these are kind of, the species look similar. They maybe aren't necessarily related, but kind of recognizing that there is possibly similar species that have evolved over different evolutionary kind of lines. So looking at the fact that we have similar organisms in similar environments. So in similar ecological conditions or habitats, some animals have developed similar characteristics to deal with the pressures, similar pressures. Sorry, that doesn't really make sense. Have developed similar characteristics to deal with kind of the pressures of the environment, which then lead to the natural selection. So also kind of getting this idea of, wait, things might be different, might have evolved differently, but they're all going to evolve to be best suited for their environment. And that's why we get kind of similar looking organisms based on the environment that they live in. The other piece for this is the homologous body structures. So looking at kind of structures that maybe have different mature forms but are going to develop from the same embryonic tissues. And this is in the sense of limbs. So limbs are constructed from similar bones. They might appear differently in different organisms, but they're actually constructed of similar bones. And it provides strong evidence that all four-limbed vertebrates have descended with modification from common ancestors. So if we kind of look here, this gives a better kind of picture of this, of looking at the homologous structures of the different bones in here. And I kind of like the color-coded one, so it kind of will show you what we're looking at for similar kind of bone structures. So they're forming from the same thing. Yes, they all look different and they have different functions, but we can kind of see how these might be related based on these different structures. Vestigial organs, these are may resemble miniature legs, tails, or other structures, but they provide little or no function in many of the organisms. So these are kind of organs that no longer have a use in the specific species, but are still there. We think of humans and the appendix, or the fact that we have a tailbone, but we really don't have the rest of the structure for that, versus in other organisms, these things are critically important. So vestigial organs are really the ones that aren't really necessary for that species. So why are these kind of important, and why do they give us that link? Well, again, just recognizing that these organs might be in other organisms and serve a purpose. But the idea behind this is that this vestigial organs, they don't really help us and they don't really harm us or the specific species. And that's why natural selection hasn't really kind of weeded them out, because they don't harm, they don't prevent the survival. Our lack of tailbone hasn't necessarily affected our survival. So natural selection focuses on the things that will either help or harm a species and its survival. So again, we can look at our homologous structures. We also can look at the different, we look at the stuff that we have here, looking at the different structures and how things are related. So the homologous body structures give us this idea that coming from similar kind of links, because we have these different body types that are similar in a sense, but might have evolved differently. And the last little piece of this is the similarities in the embryology. So in early development, many organisms are nearly identical to each other. And because of this early kind of development, it looks like they could be related through past ancestors. This also shows how homologous body structures may be formed if we're starting with the same kind of embryonic structure and then just evolving from there. It would make sense that some of this homologous body structures, they're forming from the same type of stuff, just with little variations. So if we actually look at our embryos here, where we kind of start and where we kind of end up, and we notice some similarities. Obviously there are some differences as well, but this is one kind of piece of the puzzle that gives us that idea too of some of that evolution in here, and the fact that in early development some are kind of very similar, giving us this idea that we must have come from similar ancestry. So to summarize, and again, all of this stuff in here was really kind of Darwin's work and what he put together. And granted, some of the stuff that's in here is stuff that we've kind of added to as science has progressed and we've gotten more information, but really the summary of Darwin's work is that individual organisms differ. Some of this variation is heritable, meaning they've inherited it as genetic. Organisms produce more offspring than can survive, and many that do survive do not reproduce. So this is kind of this idea of there's competition, and because there's competition, many are not going to survive, and some that are survive maybe don't even have that opportunity to reproduce. Because there are being more offspring that can survive, there's this competition for the limited resources, and because of that competition, that's where we get into kind of the genetic side of things and the inherited traits. So individuals that are best suited for that environment where they have to compete for the resources, and they don't always have the likelihood to reproduce, individuals that are best suited for it are the ones that are going to survive and reproduce. And if those are the ones that are going to survive and reproduce, these are the organisms that are going to have their traits passed on to their offspring. And this causes kind of change over time. So if we looked at the entire, beginning population, those that had those variations, those genetic mutations possibly that have made them, either stronger, faster, have a better ability to camouflage or hide or escape from predators, those are the ones that are going to pass on their genetic traits, and those traits are going to kind of continue to go on so long as they make the organism able to survive. Species alive today are descended with modifications from ancestral species that lived in the distant past. So his whole thing was this idea that species are kind of evolving, and they're continuing to evolve. They always have evolved, and it's based on that idea of what is going to make them best able to survive and reproduce in their environment. So the puzzle of life's diversity, it really comes down to this idea of evolution, that things are changing over time. Again, Hutton and Lyell were the ones that kind of looked at the geological features, saying, hey, these are changing kind of over time. Things are not the same as what they used to be. And Darwin was the one that really pushed this into kind of looking at living things, looking at species and how do they change and evolve over time. So he actually defined evolution as really the change of a species over time. And a change in the sense of making them able to survive in their current environment. So theory, we call it the theory of evolution, and a theory is really a well-tested, yet to be proven wrong explanation for a set of observations. So again, this has been well-tested. Many people have done experiments on it, their data has supported this idea, and so theories is just more than kind of a hypothesis. It's been proven over and over and over again. And the evolutionary theory is the well-tested explanations for the set of observations of change over the time. So the change over time of our different species or organisms that has yet to be proven wrong. So again, some people get this kind of idea that, oh, theory, it's not really necessarily true. Again, theories like this, they have been well-tested over and over and over again. And the theory is changing a little bit as we get more information and we think of that Archaeopteryx, and how we're gaining more information, and we're starting to fill in some of the links for that. So this ends the video notes for chapter 15, section 3.